Login accepted.
Presentation today on hacking the World Wide Web. We'll be going over, how to break in and hack different websites and the common attacks associated with web applications. And before we get started, we're going to go over a brief review of what we did last week.
So last week, if you guys were here and remember, we went through some packet tracer and we also went through the basics of networking. And hopefully you guys continue to work on that throughout the weekend. If not, no worries. But as I said last week, you guys are free to continue working on that lab as much or little as you'd like. But I would like to just briefly talk about what we did last week. So last week we went over on the Tuesday meeting various networking concepts such as the OSI and TCP/IP model. We went through what the various layers are and what they did, specifically focusing on layers 2 through 4, as that's what we looked at in Packet Tracer. We went through the encapsulation and de-encapsulation processes and how the information travels across the network, specifically using the simulation mode in Packet Tracer in order to get a more visual understanding of how information moves. And then we also looked at the Ethernet and IPv4 header fields and also using that in Packet Tracer as well so that we could see more information on that and also using it for diagnosing purposes in case there was an issue with our network. If you guys remember in the part 2 of the misconfigured network we had last week, that was a lot to do with that. And then for the Friday workshop in general, we had you set up a network based on the topology that was assigned to you as a part of a fictional business as a network engineer. And that was inspired by a lot of the Cisco CCNA practice labs. And I think that's about it.
All right.
Sorry. So if you want to review the slides or if you'd like to review the workshop, we got the links up here. And then the briefing packet, if you'd like to review that, is also on that QR code. And yeah, thank you.
And we also have our previous recordings posted on our YouTube and in our Discord, along with the links to the briefing packet. Now, getting back into our schedule, we're starting the October month, and that means that we're going to be focusing on mainly offensive security for this month. And that's because we're going to be building up into an event that we call SCARE. This is Swift's attack, crack, and root event, and we'll be covering web hacking, Linux hacking, and Windows hacking, and be able to basically accumulate all that knowledge into our SCARE event, where you'll be put to the test and get to attack a network and write a report on it as well. Lastly, we also have our membership program still open. This is $20 a semester and $35 for the year. It offers alumni mentorship where we pair you one-on-one with an industry professional that gives you insights and answers any questions that you may have. And to introduce ourselves, my name's Ryan Miller. I am a computer science major and second year and the current co-director of Academy. I was on the 2023 NCAA Cyber Games competition team and currently on the CPTC and CCDC teams for this coming year.
And I'm Dylan Tran. I'm a computer information systems major and I'm on my 4th year. I was the director of Academy last year and I competed on the competition teams for the past few years, not this year though. And I'm currently doing some adversary simulation work with IBM's Express Red team.
And to give a quick overview of what we'll be covering today, we'll be covering the basics, what you need to know about web applications and the protocols in use. Then we'll be talking about the methodology that you'd go about attacking a website, what are the kind of steps that you would need to do. And lastly, we'll be covering the common attacks that you'll see on a lot of websites and the ones that you want to test for when you're attacking a web application. So to get started, we're with the basics. What is a web app? Well, web applications are software that is accessed through a browser. So a client will open something like Chrome and be able to type in a URL and access a website or a piece of software that is hosted on a server. And this web application is split into two main parts. That is your front end and your back end. And your front end is going to be the interface, what the user actually gets to see. This is mainly there to look nice and make it easy to access this information, and is built with languages such as HTML, CSS, and JavaScript. And then you have your backend, which is going to be really what makes the application run. It's your logic behind everything, and is mainly built on processes or languages such as PHP, Java, Python, and Node.js. Now, I want to cover a general idea of how web applications work. This is going to be from the perspective of a normal client who is using the user interface. However, it should be noted that you can interact with websites and web applications through a terminal interface as well. But for what most people are comfortable with, we'll be talking about the front end to give you a better idea. So we're going to take an example such as the client clicking a button. This is going to craft an HTTP request and automatically send it to the server. And then the server will take this HTTP request, run the functions and processes associated with it, determined by its backend coding, and then generate a response to give back to the user. And this was often, but doesn't have to update the front end. So we'll be giving an example here.
So let's take on your computer, your client for any sort of web application is typically going to be your web browser. Although like Ryan said, you could technically use the command line. Let's just say as an example website, I'm using Roblox, right? And over here, I could see the front end shows me that there's a list of users on my friends list that I can view, and I can view the profiles if I hover over their character icons. So if I hover over the Mario Sonic 844 user and I click view profile on it, that's going to send an HTTP request to the backend. With that HTTP request is going to have some data sent with it. The backend is going to process that data and that request, and then it's going to respond with some data that my browser or my client can use to render the information. On the terminal, this may just show up as pure text, but in this case, as your browser is actually going to make it a visual, in this case, the picture shown below. So when it comes to HTTP requests, there's several methods which are a classification of the type of requests. There's going to be a get, post, put, delete, head, and options. There's a few more. The most common ones that you'll run into are get requests, which get data, so just read or retrieve. It's probably where the name get comes from. Then you have post, which sends data to the server. So in this case, when say you're logging into something and you have to send in your authentication credentials, that data gets sent to the server typically in a post request and not a get request. Then you have the other requests, which are a little less common for your daily interaction. But you have put and delete requests, which modify the state of some resource on the server, and then you have head and options, which typically return to you some metadata. So as an example get request, let's just say this time we're using When to Meet, which is an application that when you access it, helps you sync up your schedule with and coordinate a meeting time with other people. So when you access When to Meet, you just enter the URL into your the bar on top of your browser. What that actually does in the backend is it's going to send a GET request with all the information on the bottom left, and then the server is going to respond with the information to create a render on your client side, which is going to be on the bottom right. If we take a look at this this request a little deeper, we can see it's broken up into several parts that we've color coded out. The green part being the identifier for what type of request it is. In this case, it's a GET request. And in the red is the path to the page or endpoint that you're trying to access, because when you send a request to a different page or endpoint, the server has a different response and different way of handling it on the back end. Then after the question mark, we have the text labeled in purple, and that's called a URL parameter. When you send a GET request, you have the option of sending additional data through the URL in the form of this format. And then in blue, we have metadata that's sent with the request, in this case, the headers. And in orange is their value. In this case, the user agent helps identify who the client is, so maybe what type of browser if you are using a browser and what type of operating system you're working with, although this can be easily modified. And then you also have the host, which indicates what host this request is trying to be sent to. And for a post request, as I was saying earlier, it's typically associated with things like login forms or anything where you have to send more data, and typically data that you want to be in a more secure manner, because for get parameters, they're sent through the URL, so they're easily visible. You don't want to put any sensitive information there. Whereas post request, it's set in the request body, which is a little harder to access off of, like, say, pure logging. Now, for this post request, I'm putting in my information on the left over here. In this case, my username is Redleaf and my password is something in that form. When I click enter, it sends the request on the right. Taking a look at this request a little further, we can see in green, once again, is our request type, post, and then in red is also the page or the endpoint that we're sending this request to. The headers are again there, but we didn't label them this time. And in the pink and yellow are the parameters and the values of those parameters. This is one format of ways that you can pass data in through a post request, but there's other formats such as JSON, or you could even upload binary data, which makes a post request more flexible when it comes to passing in data to a backend than a GET request, which typically is just going to be passing text values or numbers through the URL. And then after this request is sent to the server, we get a response. There's different classifications for these response codes, and it's really up to the application whether or not they want to implement these responses. But in general, 100 to 199 is going to be some sort of informational response, whereas 200 to 299 is going to contain some sort of success code or indicate success. So oftentimes when you access a website and you actually get what you're intending to look for, such as the renderings that we showed earlier, that's often 200 success. Sometimes though, when you access a URL, you get sent to another website or another page on the current website that you're on, and that's called a redirect. If you inspect the request of the series of exchanges of requests, when that's occurring, you'll probably see that there's a 301 in the middle, which is indicating that the redirect is occurring. Then 400 to 499 are going to be client-side errors, such as 403 and 404, so access denied, or resource not found, which you may be familiar with. If you're trying to access something, but you didn't log in, or you're trying to access a page or endpoint that doesn't exist or doesn't have any sort of logic prepared to handle it. Then 500 through 599 are going to be your server-side errors. So maybe you sent a request, and that request, the backend that was supposed to handle it was improperly coded, or maybe you sent a bad request to a particular endpoint. The server may crash and return to you that 500 something and say, hey, something broke.
And lastly, for what we want to cover on the basics, I want to talk about the data storage types that are handled by a server. And this is very important because understanding how the server that you're interacting with is storing or handling your data is important to know what kind of attacks you can do with it later on. So the first type I'll cover is persistent or stored data. This is data that is taken by the server and stored in somewhere in their backend, whether that be a database or just on their file systems. This data will persist even if you log in or log out of your account. And it can become publicly accessible data in the case of something like a social media post or a comment that are supposed to be publicly visible to your clients. Additionally, I have file uploads listed here, which can be a particularly dangerous form of persistent and stored data. Secondly, we'll have the session data, and this is data that is going to be stored in cookies and typically will exist for one session or one connection, and controls important data such as your sign-in status or a shopping cart. The reason that this is very crucial is because a cookie that is storing your sign-in status can also be used to determine whether or not you're authenticated. And that means that if I'm storing a cookie that says I'm logged in, then I can move across different parts of that website without having to re-log in again, and that provides you a sort of single sign-on ability. However, this is also dangerous in the event that an attacker can steal your session cookie and then just log in as you. Lastly, we have ephemeral data, which exists for just your one HTTP request. It's not stored, it's not saved. This is typically just data that exists for that transaction to actually occur, such as your destination URL, but it doesn't really matter outside of that. Now we'll be talking about the methodology of attacking a website. So we have a diagram up here that covers mainly the first part, which is your enumeration. When you're enumerating, you're mainly going to be looking for different directories of that website, different pages that are available, and also trying to discover if the software that you're dealing with is known or not. If you are dealing with a known software, then that means that there might be existing CVEs or vulnerabilities that exist online and that you can exploit just because it is an outdated or it's a known software with maybe outdated software on it. However, there's a lot of cases where you also have unknown or custom software that is built maybe by the company themselves. And in this case, you're going to have to do a lot of your own enumeration, see what inputs the website takes. But by no means is it not vulnerable just because it's an unknown or custom software. So kind of getting more in depth with the enumeration, you want to be looking at the functions of the website, what it is trying to do, and how what kind of user input it's taking in, because that's often where you're going to be able to exploit it. Additionally, I have the version numbers and pages listed here, and some of the tools that I use often for this enumeration phase is going to be your Wapalizer to discover any technologies on that website, a GoBuster for directory and subdomain discovery, and Nuclei for discovering those known vulnerabilities. Next, we'll be getting into the research stage, where once you know what technology or what kind of inputs you're dealing with, then you can research what you can actually do with that. So if we know the software exists and we know it's a known piece of software, then let's start looking up any CVEs. We can do this in ExploitDB, Rapid7, or GitHub. They're all great places to kind of contain that sort of information and have discussions and also potentially scripts on that. Additionally, we're going to be wanting to look at common attacks and anything that kind of relates to our website, what kind of inputs that we're taking. We're going to want to see what common attacks we can actually do with that. One great place to start is OWASP, which is a collection of the of different web vulnerabilities. And it describes to you like how you can actually exploit it and what would be required to do it. Lastly, the only thing left is basically to exploit that web application. Exploit and try to basically get an unexpected or unauthorized result out of the server. This can be done basically, I mean, on websites, you're mainly going to be kind of just doing it through trial and error. It's kind of hard to, you can never know like what the website is really taking on the back end. So you have to try a lot of different inputs. You have to try a lot of different payloads and different endpoints to see if you can get it to respond in the way you want. This is mainly done when you're doing it manually. This is going to be done through Burp Suite or other ways of modifying your HTTP request. However, in the case that we do have a CVE, we can actually use software like Metasploit or GitHub to automate that process as someone has made like a script to basically run through that known vulnerability. And now we'll be getting into a quick live demo of what Burp Suite is and kind of how to use it. Can you put it? All right, so what I have here is a website called the OWASP Juice Shop, and this mainly has what I want is the user registration page. So what I can do is I can open up a Burp Suite and open up a proxy to send my traffic through, and then I'll type in some dummy information that we're going to be changing later. And while Burp Suite is kind of a, oh wait. a long process to kind of start up here. We're going to be covering two major tools of Burp Suite, which is going to be your proxy and your repeater. So the proxy is what's going to be able to intercept my web requests and allow me to modify them. So when I start a proxy on my server here, and I also on on Firefox, and I turn on the intercept here, when I click register, my request actually won't go through immediately. If I go back to Burp Suite, I'll see my request right here, and it's basically just waiting for me to send it through. And if we look at the bottom, we can also see the data that's getting sent through, and I can see my email here. What I can do with this is that I can actually change my data before it's actually sent to the server, and what I'm going to name it is redleaf@gmail.com. Now, when I forward this request and I stop my intercept, I can actually, even though I was registering as bra@gmail.com, I can now log in as redleaf@gmail.com. And you can see that my account is redleaf@gmail.com now. Now that is one function, but the other function that we have with the login of Burp Suite is the repeater. And what I can do with the repeater is that I can send my requests that I have captured already. I can send it to the repeater with either Command R or send to repeater here. And what I have is that I now have a request, an HTTP request that I can just send through multiple times and also test different queries with. So if I test something like redleaf2 and I send it through, I'll get a response that says success. I can also test something like if I try to send the same request twice, I'll get a validation error because my email already exists on the server side. And now if I log in with that email, I'll be able to log in with the request that I sent through the repeater. And that is some of the main functionalities of Burp and the ones that we'll be covering for today. However, there is a lot more that you can do with it as you get more advanced. And now back into, we'll be diving into the common attacks that you can do in web applications.
So what we just demonstrated isn't inherently malicious. Simply proxying your request or intercepting them and modifying the data that you're sending. What we did is we just ended up registering with a different email rather than the one we input in the form. That itself doesn't really demonstrate all too much. The real value with Burp comes in how we can continuously intercept and repeat requests to get different results. The actual requests that we're going to be repeating are going to be different. They're going to be different sets of data that we're sending in order to test these common attacks that we'll be demonstrating. This first sort of attack we're going to be covering is called a command injection, which the vulnerabilities is effectively the backend input for, or the backend processing for whatever endpoint or page that you're sending a request to. It doesn't really handle the data that's being sent to in a secure way, and it ends up running it in a command, which is why we call this command injection. Effectively, we're able to run commands through sending web requests, and these commands get run by the backend server. So for example, we have example.com, which has a page called purchase.php, where it takes in two parameters via two get parameters, owner ID and recipient ID. In the backend, now as while you test a web app, you won't have visibility into what's really going on in the backend for the most part. But for the sake of this example, we'll be explaining that, or we'll be revealing what it's doing. In this case, it's passing in those inputs for some reason into a shell exec PHP function, which is going to result in the following command being run on the command line. In this case, it's going to run a Python script passing in the URL parameters as parameters to that Python script. So the way we can go about exploiting this is rather than sending a normal ID, a normal numeric ID such as 24 and 25 as earlier, we can send that data, but also append a semicolon and write a command, or we could just substitute with an actual command itself. What this is going to end up looking like to the backend is when we send a post request, or it should be a GET request, but when we send a GET request to purchase.php, it's going to send the parameters as we see over there. And we could see that in the green, there's a semicolon that we've appended, and in the purple is the command that we've added. When we take a look at how the backend is going to process this shell exec function ends up having a semicolon and then a ping command being run. The assumption here is that this is running in a Linux or Unix backend, which typically uses semicolons to sort of combine or chain commands together. So what this is going to end up being processed as it's going to be the Python script being run with the parameters passed in and a ping command being run. More malicious commands can be run, such as ones to get a connection or some sort of other, really anything, whatever binaries are available on the file system of the server. The reason why we were covering Burp earlier is you don't necessarily know if vulnerabilities like these are present because you don't have any visibility for the most part into the backend or really the code if you're doing this blind. So through repeating requests on Burp, we can try different what we call payloads, or basically this set of data that we're using to test vulnerabilities. And we could repeat them on these endpoints over and over until we get some sort of result that indicates that the attack we're trying to do is actually successful. And then that's how we know, okay, the vulnerability is present. And we could see what is really the scope of the vulnerability by trying to perform more and more interesting actions for an attacker. The second sort of attack we'll be covering is something called SQL injection. So it's pretty much the same premise as command injection, except rather than running a command, it's modifying a SQL query that's being made by the backend. So in this case, rather than server's backend logic improperly handling parameters and running them in the form of a command, this is going to be the server's backend logic improperly handling inputs into a SQL query. So in this case, we have example.com again, and it has the search.php page, which takes in a get parameter for something to search for. In this case, the example request we're sending is searching for the word apple. And once again, we usually don't have visibility into the backend, but it's for the case of the example. And in this case, the backend is going to be running the following SQL query: select wildcard from listing where the name is like Apple. What this is going to do is it's going to return all results from the database of within the listing name column that have Apple, the Apple string within it. So the way we could try to go about exploiting this is changing our input to contain a single quote, parentheses, and then an or 1 = 1, because to the backend, this is going to result in a modification of the SQL query as shown below. And this result is going to be the server not just returning whatever items have the word Apple in them, but all the items on the database within the listing name column. And the reasoning for this is if we take a look at the new SQL query that's being made as a result of our malicious input, we can see that there's a single quote and a parentheses that closes the initial condition, which is listing name, like in this case, LMAO. But then there's an appended or 1 = 1 with a double hyphen, which is going to comment the rest out of the query. So this changes the query to be, rather than selecting a listing from matching a name to a column, it's going to change the query to be selecting a listing where it's either matching that or everything else, because the 1 = 1 is going to return true. The comment at the end over there effectively nullifies the rest of the query in the scenario that query we're injecting into is a part of a greater query, so that we can sort of guarantee that what we're trying to do is going to happen rather than the rest of the query running and invalidating the SQL statement. And then finally, well, not finally, we still have more attacks to cover, but we have local and remote file inclusion. So rather than being inputs that get processed to run some sort of command, this might occur when a server utilizes some sort of input provided by the client end to include a file or some sort of, or to include some sort of file on the page. So For example, we have example.com with browse.php, which takes in a get parameter called file, and that file parameter is going to indicate what file it's going to try to load into the page. Maybe it's going to load as an image or whatever. Now, when this is if the server doesn't take proper security measures when loading these files, then there are sort of unintended behaviors that can happen, such as a file being loaded remotely when maybe that's not what it was originally intended to do, or maybe a file being loaded out of a location that wasn't necessarily intending to do. And this could be provided, or this could be tested with the following payloads that we're sending to that endpoint. In this case, rather than trying to load just whatever image that we were trying to load earlier, if we use double periods and then followed by a / to escape the file system and head to the parent directory, and we continuously do that, we could see if maybe it's possible to load files outside of the directory that it's normally looking for, or maybe we could try to load files that have extensions if it's not necessarily checking them. And with RFI, this is remote file inclusion. We can try to load a file remotely. So rather than trying to read files off of the file system, we can try to pull in a file that we are hosting on our own server. And this can have various consequences depending on the application. For example, if it's PHP and you're loading a PHP file into the web page and it gets rendered, that you can obtain code execution off of that. But there's a bunch of different other stacks and a bunch of different contexts this can be applied in. So you really just have to continuously test and see how does the server respond to this.
Now we'll be talking about XSS or cross-site scripting, and this is an attack that it causes custom JavaScript code to be executed on the victim's computer. And because this is because it's executing JavaScript code, it will pretty much solely be targeting cookies most of the time. And that's because if you can get a user's session cookie, as I mentioned before, it means you can hijack their session, and that can have very dangerous consequences depending on what account you hijacked. If it's like a bank account, obviously they would be able to transfer all the money that you had in there. Cross-site scripting also cross-site scripting has 3 forms. However, we'll be talking about 2 of them today, and that is going to be your stored and your reflected XSS. When it comes to stored XSS, it's where a malicious payload or a malicious JavaScript payload is put somewhere on the website or the server's website, and then is publicly available for other users to see whenever they load that specific page. So if an attacker uploaded a comment with this malicious JavaScript payload, which was pretty prevalent in quite a long time ago, but when the internet was less secure, that meant that whenever a client uploaded, or whenever a client would load that specific page with a comment on it, then your malicious JavaScript would be loaded, and that would cause it to acquire the cookie, the user's cookie, and then send it over to the attacker's server. Then we also have the reflected XSS, which is where it only exists in one request, and that is going to be in the link. So you'll append a malicious JavaScript query to the end of a link, and that query will be doing the same thing where it's taking your user's cookie and then sending it to the attacker's server. This is a little less dangerous because it requires the victim to actually click on the link and interact with you, so it falls into some sort of social engineering. However, it is still very dangerous because that one misclick is going to cause you to lose your account pretty much. So how can we actually exploit cross-site scripting? Well, the first thing that we'll need to do as an attacker is to create a HTTP server to receive the client's or the victim's cookies, and then we can do it in multiple ways. As I mentioned, there's stored and reflective, but in this case, we'll be doing reflective because it's easier to show. And we'll be appending to the end of this URL a file. And this kind of calls back to the RFI, if you remember earlier, where we can host a malicious HTML payload on our on our attacker computer, and that payload has the malicious JavaScript in it. This isn't the only way you can do it. You can directly add the JavaScript to your URL. However, we wanted to talk about the integration between these different attacks as well. Now, when the user or the victim ends up clicking on this link, we'll get a response on our HTTP server that we're hosting on our attacker computer that will look somewhat like the request at the bottom, which is a GET request that sends a URL parameter with our session cookie. And I have excluded the session cookie with dots because they tend to get very long. So, but you can see the kind of response here that would be due to a malicious XSS attack. Now we'll be covering the mass assignment vulnerability, or mass assignment attack or object injection. This by itself is not really it's not technically a attack because it is a feature of it's a feature for developers to easily assign different variables depending on user input. However, this becomes a problem when developers are careless and don't account for unexpected parameters being added. And if they send like an entire post payload into their assignment, then you can accidentally assign a role that you didn't want to or a variable that shouldn't have been there. So I have an example here of a vulnerable code on the server side, which is trying to create a user class and basically just sending the entire post request of your user in its parameter. And if we look from before, we're normally only supposed to send the username, the password, and the email in that form. However, our user class has a few extra variables that are normally just going to be assigned and manually changed later on, depending if they're needed or not. And this is the isAdmin or your organization variable. Of course, we don't want a normal user to be able to just make themselves an administrator. So this is what makes it dangerous if our client then decides that they want to take their normal post request to our register page and then append a new variable. So if we take a look at as long as you pay attention to the format that your post request is originally in, you can add additional data that in most cases is not going to be handled if the server isn't accounting for it. However, in this case, because the server is just passing the entire post request, then when we add the isAdmin variable and we assign ourselves it to true, then the server will just take all of our data and then send it through. And because that isAdmin exists on the backend when we're doing a mass assignment, it'll just be set to true and our new user will just have administrator privileges. Lastly, we'll be covering the server-side request forgery attack. And this is where unauthorized users are able to access internal pages through the server or through improper server sanitization and access of websites. So in a normal HTTP request, and to give you an idea as to why this occurs, we'll take a client who's trying to access the stock of a product through the product/stock endpoint. And when this client sends the request to the server, we can see a little inspection of what post request is going on. We'll see that it's trying to make a call to the stock API with the link here, and it's just going to, the server is just going to make that request, get a HTTP response, and then send it back to the client without really checking if anything is going on as it should, or if that's the right URL. And when the server returns, this will normally just return the stock of whatever product that we are trying to check. However, this can be dangerous if, like we showed with Burp, you can edit the request that is getting sent out to the server and basically edit the URL that the server is going to request on. So as you can see in this post request, we have changed the stock API URL to the localhost/admin. And this means that now when we send our post request to the server, it's going to think it's calling to the API and just use the URL that we gave it. However, now it'll be accessing the admin panel on the local host or the intranet. Or if the local host, or it could be on a different server on your internal network. And this will then return a unauthorized view of your internal admin panel, which if it's on your internal network, it obviously should not be public. It should not be accessible. This doesn't mean that, like, if I make a request to a restricted site, like we could take the admin panel in this case. If the admin panel is blocked behind some sort of authentication, like a cookie authentication, accessing it through SSRF doesn't mean that you'll immediately be authenticated, but what it does do is that it allows you access to those internal servers. Maybe there's a GitLab, local GitHub lab that is hosted on your internal network, and you'll be able to have unauthorized access to that, which is very dangerous. If, like with the GitLab, if you have code on there that can then be used for further analyzation and exploitation by your attacker. And I think that's all we have for today. So if you guys have any questions, feel free to ask them, and we can go over any clarifications. I got like 7 minutes.
What would you say is like one of the most dangerous attacks that
It depends. It really depends on where the context of the exploitation is happening in, right? For example, session stealing is pretty bad, but if it's on a web application that doesn't really have any sort of functionality or isn't really have no business use case, then that session stealing, let's say through XSS, doesn't really impact much. Or, but let's just say you have SQL injection, right? And if the SQL injection is on a production database, that would be really bad. If it's on a decommissioned database that has little to no information on it, it doesn't really matter. So it really depends on what asset has a vulnerability. And yeah, I guess that's really the primary thing. Oh yeah, what's up?
What do you use to mitigate these vulnerabilities?
It really goes on a case-by-case basis because there's different mitigations for each of these vulnerabilities. I guess let's see, how can we?
You just pick a simple example.
Sure. Let's see. So let's say, all right, SQL injection, because I definitely didn't work with this one very recently. With SQL injection, if your backend handles the query, so in our example, what we did is the query takes the parameter and just fits it into the query that's going to be made by the backend. For most web applications, they have support for something called parameterized queries. It's typically going to be some sort of programmatic library that helps you effectively do all the sanitization, so you don't have to manually implement it. And through that sanitization, your query is going to be generally much more difficult to inject into. There's still additional safety concerns, such as type safety, depending on your language, such as JavaScript, that you can have to take into consideration. But in general, you usually use some sort of library to help sanitize your inputs into a parameterized query. Yeah, what's up?
mitigations for which isn't so dependent on something like sanitization?
Okay, so for SSRF, that's a tough one. I feel like I know why you're asking me this one. Okay, mitigating SSRF. Off the top of my head. Well, I think it would partially, it would depend on when the well, if the backend is supposed to be able to send a request to a particular endpoint, then the mitigation is going to differ whether or not like the request was supposed to be made at all. If you aren't supposed to be able to send, if it isn't supposed to make a web request to begin with, and it is capable of doing so, that's going to be one line of action that you can take. Beyond that, it would be pretty context dependent, I think.
URL whitelist.
I mean, there's that, that, I guess that is one approach that you can allow list specific URLs, depending on the endpoint, or you can change how specific URL endpoints are able to be accessed. I know in the case of AWS, they have a metadata endpoint that's only available internally. And rather than it being accessible through a single request, they made it through a series, which is much more, a series of requests, which is much more difficult to obtain through SSRF rather than through a single request. Oh,
Given a very vivid presentation, and it was very informative. But my question is about, is this information about the Burp website, or is this general internet web browsing?
this is about a general methodology to approach testing web applications. In the career of offensive security, web applications are extremely common when you run into them because basically everyone's running them. And when a client wants you to test their infrastructure, oftentimes it's going to involve testing that. So we wanted to provide both the skill set and the methodology that's involved to approach that scenario.
And a wide range version.
Mhm.
Okay, so basically this technology can apply to me going on my day-to-day internet browsing and bank checking, that kind of stuff could apply.
You could definitely apply some of the information that we've done here to your day-to-day processes. If you wanted to see, if you wanted to proxy all your traffic through Burp to see what a website's doing in the background or what clicking a button really, what information it really sends from your client end, then you could definitely apply some of that information went over here.
Right, we're gonna wrap it up actually, because there's a class coming into in a few minutes. I would like to thank IT for the pizzas. If you haven't signed in already, please sign in. And lastly, I would like to thank Cisco and Splunk for dropping by and seeing our presentation. Right. Thank you, everyone.